everybody, I'm Dave Weyer. I used to be the amp and effects builder at West Coast Organ and Amp Service in Hollywood, California back in the heyday of rock and roll in the summer of love. During that time, we modified thousands of amplifiers, Marshall, Fender, many other brands, all for the big rock stars of the day. Most of Jimmy's Woodstock gear was built or modified at West Coast, for example. Many of the modded units were fitted with a small oval sticker advertising West Coast Organ and Amp Service. And because of that little sticker, some of these pieces have followed me to this very day. If you'll bear with me for a few minutes, I'll take you through a recent rebuilding of a Marshall Major, which was probably made sometime in late 1967, and which has been upgraded to take advantage of many of the techniques I've learned since my days at West Coast. We'll go out into the studio and have a few friends come by and play the amp, and I'll take you through the circuits and controls so you can have a listen for yourself. Please enjoy, and thanks for watching. Okay, everybody, here's the Marshall Major. I'll just run through the controls real quick for you. It's a standard set of Marshall controls, except for over here, as you can see, the two input jacks have been replaced by a crunch control here and a master volume here. Otherwise, they're all the same, except for over here is the what used to be the presence control, which now is a sheen control, which puts a high-end sheen on everything that passes through the amp. And this particular Marshall Major has a polarity switch. That's not shown on the later diagrams. So crunch control has 6 different settings, starting at minimum crunch and then going all the way up to the 6th position where it has a lot of crunch, as you can probably hear from the recordings. Anyway, that's how the front panel looks, and there's a new little label down here to designate the crunch control and the master. And of course the master allows you to turn the input volume up here and run the wave compressor circuit without having to have the amp turned up loud. And all the things that we are hearing or just heard were played with the master volume, putting out allowing the amp to put out maybe 10 or 20 watts. That's all that's really needed. You don't have to run 200 watts to get a sound. So now I'll flip the chassis over and I'll run through the tubes for you so you can see what those are. And now here's the top of the chassis. As you can see, there's a couple of extra tubes that are here that weren't here, and the tube complement is changed. This first 12AT7 is the wave compressor tube, and then there's the 12AX7 standard Marshall input tube. From there, things change to a new gain tube that's been added. This is a 6KZ8, and this allows a high level of input gain in order to run the wave compressor. And here's a 5687, which is a cathode driver for the output tubes. And then two 12AT7s are in the output section of the amplifier. One of them drives the tone controls, and the other one drives the output tubes through this 5687. The output tubes are now KT120s, something we didn't have available back in the day, but they can handle 250 watts with no problem. Actually, not even working hard. So that's the output tube situation. KT120s, they're readily available and quite inexpensive. And this is the standard back plate, this Marshall Plexi. And over in the corner, you can see the veritable West Coast sticker. Now I'll flip it over and I'll show you what the underneath looks like. We'll start over here, take a look at the bottom of the chassis. Here's the 6-position crunch switch. Here's the wave compressor tube, and this is the wave compressor module. What this essentially is a tiny little push-pull circuit that acts like a power amplifier without having to actually have another power amplifier. That's how it gets its crunch. So that's the wave compressor tube, and then here's the 5687, which is the cathode driver for the output tubes. Its main purpose is to drive some power into the output tubes and to keep their impedance very low, so it helps keep them from blowing up. Any of you Marshall fanatics have probably experienced that. Tone controls have been moved. They're here now, and they're moved directly in front of the power amp, like an old 59 Fender Bassman. This over in the corner here is a MOSFET screen regulator. It keeps the MOSFET keeps the screens at 408 volts under any condition, which puts this amplifier back to pure pentode operation. Over here in the corner, you can check out, these are the cathode resistors, and there's a cathode fuse. Since the high voltage fuse never blows on these when there's a problem, I put another fuse in the cathodes to act quickly if something should go wrong, save the output tubes, maybe the output transformer. Down here in the corner is a hum balance control, which is on the filament supply, which allows you to turn up the input volume with no guitar in and listen for hum, and then you just adjust this and it dials the hum out. These are radio frequency chokes. They help keep oscillations out of the output tubes. And we have an extra power supply capacitor added here to cover the extra needs of the 2 extra tubes that are here. This is a tiny little filament transformer. It runs the filaments on the 5687 because they are at a high voltage potential and they need to stay off of the other filaments. So that's kind of how the underside looks. Okay, for those of you with the technical mind, here is the schematic of the amplifier. It's all laid out. I'll just run through real quickly so you can see. This is the standard Marshall input stage. Oh, this one has shared cathode, which had been changed from the original split cathode. The output of those runs over here into the pentode section of the 6KZ8, and that develops between the 2 tubes a gain of about 14 or 15,000, and this is fed into a cathode follower, which then drives the wave compressor module, the 12AT7 here, and it's controlled with this switch. Here's a representation of the switch that sends a certain amount of the signal into the wave compressor from very light to pretty heavy. All of this comes out into a recovery amplifier, a 12AT7 here, which is a feedback amplifier, and it has this is the sheen control that controls the amount of high frequency feedback in this particular stage. This one drives the tone controls, which are now right here in front of the output amplifier. There's Zener diodes on here to protect the output amp from getting too much signal. And then we go into the 12AT7, which is called a floating paraphase inverter, which drives 5687 cathode followers into the output stage. This circuit down in the corner is the MOSFET regulator, which feeds 408 volts to these screens at all times. And then, of course, up here is pretty much the standard Marshall power supply with the addition of a couple of extra stages of capacitance and a tiny bias supply, which runs down here and biases the wave compressor. And then it has the usual center tap series capacitors at the input of the supply. Didn't have enough room to show the transformer, but most anybody that's seen Marshall circuits knows what that's all about. Anyway, that's the general rundown of this. So those of you that are a bit geek-minded can see what's going on.
Still had a lot of body that you never get, and that's one of the things that's very different about this amp. And the other thing I found was when he had it tuned a little bit more aggressively with more treble gain, it had some of the characteristics of a AC30 cranked all the way up. The old vintage ones had that incredibly aggressive, brutal high end, and this can get that too. So, and then it could be very mellow and bluesy and sweet sounding too. I think it's the most versatile Marshall amplifier I've ever played.